Okay, so you're going to write a system of linear equations to model the following problems and then solve it. Okay, so you want to determine two numbers such that their sum divided by 4 is equal to 14. Okay, so we are kicking it up a little bit because this isn't as straightforward now. It's not x plus y this time, right? And the greater number increased by 24 equals 3 times the smaller number. Okay, this is a little bit harder, a little more like it's more orders of operation here, but the idea is still the same. Okay, so I can break these things into parts. Okay, remember I'm after two equations. Okay, so you want to determine two numbers such that their sum, adding, divided is obviously division by 4, obviously, equal to 14. Okay, so I'm just going to say, okay, it's the same let statements as earlier. Let x represent the bigger number, and then let y represent the smaller number.
Can you also write let x represent the first number?
Sure, yeah. First and second is fine too. Okay, so let's just deal with the first piece here, right? If we worked under this, this is a very general skeleton like what we did earlier. Something like x plus y has to equal 14, okay? And then I can add in the extra pieces. It said sum divided by 4. Okay, so you got two numbers, you're going to add them together, and then it says if I divide them by 4, it's equal to 14. Sorry, not 14, 4. Does that make sense? Yeah, I'm just doing what the words say, okay? But I'm like breaking it into pieces. Okay. Then I'd say, I'm going to deal with the second sentence, right? The greater number, we said the greater number was x, increased by 24, right? X, bigger number, increased, sounds like a plus, 24, is equal to 3 times the smaller one. Okay? Now, I'm just thinking, okay? Because I don't know. You could do this with elimination or substitution, doesn't matter. You are going to see, be able to make a decision as to which one's easier, okay? But I'm just seeing if substitution is going to be too hard here, because it's done with elimination in my solutions here, okay? What I think you can do, okay, we've got two equations, right? Obviously, 1 and 2. I can get rid of the fraction in number 1. Okay, I can multiply both sides by 4, right? That's going to produce a third equation that looks something like this. X plus y is equal to 14 times 4, 28, and 2 is what, 56? Am I right? Okay, that's just this one here. All I did, here, I'll write it down just so we know what's happened. I brought the 4 up and I multiplied, right? Or multiplied both sides by 4. Okay, that turned into 56. Is that okay? Can I get rid of that? It's just bugging me. I just want to write 56. Is that okay? Now, if I choose to use substitution at this stage, you're going to have to get a variable by itself. I don't see any variables by itself right now, right? Kind of stuck. What you can do, number 3 looks kind of simple in the sense that I can just take one of the variables and move it to the other side, and lo and behold, I have one of the variables isolated, right? So again, doesn't matter which one it is, you're just going to move one. Why don't I just take, it doesn't matter, I'll move x, okay? And take x and move it over, so I'm going to subtract x from both sides. Okay, so this is what I'm going to get here. 56 minus x. Okay? Yesterday we discussed, this was like boxes and, squares and triangles, right? Yesterday? What you've got here is you've kind of got you've got one triangle is equal to 56 minus a box, right? And then, since you've isolated in the first equation for x, you have to use the second equation to solve for y. Okay? It's hard to jump back and forth in acronyms here. Or analogies, sorry. Okay? So, what I'm going to do, I have what y is equal to. It's equal to this piece. What substitution says is I'm allowed to substitute it in where I see a y. This whole piece is going to go in for where the y is. Because it told me that y was equal to that piece. Right? So when I come down here, I'm just going to switch 2. I'm going to rewrite 2 with that y piece replaced. So I get x plus 24 is equal to 3 times, here's the y piece, it's going to slide right in here, 56 minus x. Now I don't see any more y's, right? That's the idea. I only have one variable to solve for and that's it, right? Is everybody okay? So I kind of did this in a horrible order. I don't know where you guys have written it. I'm going to move this over here. You should, I don't know, you shouldn't, it's good practice to work left from right, like reading. Is that too small for everybody to see? Is it okay still?
Yeah, I think a little bigger.
Okay. Like this? I have the ability to do that. You don't have the ability to do that with pencil and paper, unfortunately. Okay, so now I'm just going to work up. All I'm after, I need a value for x. Once I find x, what is x? It's the bigger number. Once you find it, it tells you what it is, right? So you're just going to do the math on it now to find what x is. So I get x plus 24. Now, remember what I got here. I got these jail bars. I got to get rid of them. How do I get rid of the jail bars? I multiply the 3 in. Do we have what 56 times 3 is? I can't do that in my head. Not on the spot. It's too much pressure.
What is it?
56 times 3. 168?
Yeah.
Minus 3x, okay? Now, you've got apples and you've got oranges. Just collect like terms, right? You're just going to move the variables over. You're going to move the numbers to the other side, okay? So I'm going to take the 3x and I'm going to move it over. Okay, and when I do that, I have to, or in order to do that, I have to add 3x to both sides, right? So in the next step here, you're going to have x plus 3x plus 24 is equal to 168. And then I see I could take the 24 and move it over. And to do that, I'm going to subtract 24 from both sides. Okay? And so I'm going to get a statement that looks like this. X plus 3x is equal to 168 minus 24. Now you're just doing math. 4x is equal to 168 minus 24. 148 minus another 4 is 144. Am I right? Divide both sides by 4. X should equal 36. Am I right? Okay. Then what? Now, this is no different than the elimination process now, right? I have one of my pieces. I'm going to go back to the equations, and I'm going to plug it in to find the other one. And by one of the equations, I mean either 1, 2, or 3. You can pick the easiest one you want. The nice thing about the third one is I've already isolated for y, which is what I'm looking for. That's what's nice about the substitution process. You don't necessarily get that with elimination. You always got to have the isolation piece at the end to find the variable, right? But I know y is equal to 56 minus x because of this right here. So you just plug in the x value, and then you're done. Y is equal to 56 minus 36. There's a 20.
Do we need to write our POI at the end of this?
Okay, so the difference with this, it's a good question. I was going to talk about this. With word problems, you're not necessarily, well, you are discussing the point of intersection, but you now have provided context around what that point of intersection is. Specifically, with these two lines, you can write a therefore statement that says the bigger number is 36 and the smaller number is 20. I will be happy with that. Is that okay? So therefore, it's at this stage though, you have to be careful, okay? If you say the bigger, well, obviously you wouldn't say this, but the bigger number is 20 and the smaller number is 36. You wouldn't say that just because this question is relatively straightforward. Does everybody see what I've done though? You've flipped what it was you solved for, right? Remember, these things can be applied to all sorts of situations. Doesn't just have to be a bigger number and a smaller number, okay? This is why I was saying earlier to be specific with your let statements, right? If you're very specific with your let statements, being that you said it's the bigger number and you've said the other one's the smaller number, then there's no way you're going to say the bigger number is 20 and the smaller number. It's just, that's not going to happen, right? It's just emphasizing the importance of being very specific, okay? From the beginning. Is that clear? Very good. Yeah.
The second question doesn't make sense at all.
Okay. Well, we'll work on this in a sec. I'll show you. Yeah.
So, point of intersection isn't necessary.
I didn't really put too much thought into that. I mean, what's the harm in saying POI is 36 and 20? Is it going to kill you? Probably not.
What if I accidentally stabbed myself already?
Huh?
What if I accidentally stabbed myself already?
It's a very unique circumstance. Okay? You're just providing like the point of intersection is the point of intersection through and through, right? It's the point that satisfies both of those linear equations. Okay, but with word problems, those linear equations represent something. So if you write a therefore statement that tells me what the two variables are, that's kind of like your point of intersection, right? You've told me what x was and what y was such that it satisfies the two equations. Does that make sense? The point of intersection is kind of redundant at that point because you've told me what the x and y were. Does that make sense? I won't be such a stickler with that. I will be with the therefore statement though. Okay, I want to see you summarize what it was you just found.
It's like a written answer at the end, basically.
Yeah. Yeah. Just something to tell me what it was you just found, right? That tells me you know what you did and why. You know? So, okay, let's go. Is everybody okay with it? Do you want to do it in substitution or you want to do elimination?
For the second,
Yeah, for the second one.
substitution.
Okay, we just need more practice. I don't know. Substitution could be a little bit trickier, especially If I see that there's fractions, if I make a substitution and there's fractions, I'm not doing it, right? You should make the same decision, right? Like, and by that I mean if you get something that looks like this, you don't want to do this. Fractions are nice, where nice is nice, if that makes sense. You don't want to create fractions for no reason. You know what I mean? This is more work than just doing the elimination process. You know what I mean? So if you decide to get and this would have been ultimately, like if I could have rewritten this. Sorry, you need two variables too. If you were to get something like this, you don't want to make the substitution of x equals y divided by 3 plus 7 over 3. You don't want to do that. That's why, again, we show you elimination, right? So you have a choice. You don't want to do more work than you need to, right? And I think that's why we try to emphasize from the very beginning, you're picking the easiest variable to isolate for, right? With substitution. Okay, so if I begin this question, I don't know what it looks like yet. If I begin this question, I start to see fraction, I'm going to deliberately choose to use elimination, right? You're going to do the same thing, yeah.
Like, are we on to the second one?
Yeah, I'm just going to do it right now. I'll see how it goes. You might be right, could be just,
Yeah, it just doesn't make sense to me because are we just assuming that like Joanne doesn't age in this 5-year period?
don't know, I think I've done this question in the past, I think that's something you got to account for. I think. Let's step through it. So what are the let statements going to be? Let's start there. I'm going to say,
Let D be W's age and G.
sure. Yeah, but are you going to do right now or in the future? This is the key, like the specific term that I'm saying.
What if you do like D1, J1, D2, J2?
Well, you're making a mess of it now.
Yeah, can I reach you?
I don't know what happened. All right, let's just say it's like, let's just say we're going to say right now, okay, their ages. Because if we say that, one of our equations is very, very easy, right? We know that the sum of their ages has to be 59. Right, so if I say, let represent Debbie's age now. Okay, and then I say, well, let J represent okay. Now, the first one's easy, right? The sum of Debbie and Joan's age presently is 59. So there's D plus J is equal to 59. The second one is probably a little bit harder. Okay, in 5 years, twice Debbie's age will be equal to Joan's age.
I kind of have an idea for that.
Okay, let's hear your idea.
Couldn't you write 2D plus J plus 5 equals... No, that's not what I meant. Sorry, 2D equals J plus 5.
Okay, one sec, let me catch up. I'm just writing down in verbatim what you're saying. We can correct it as you go. 2D equals
J plus 5.
twice Debbie's age will be equal to Joan's age
Plus 5. So like
plus
that's like in the future.
in 5 years.
J is her age right now, right? So
Yeah.
J plus 5.
Okay. You're very, very okay. Yeah, very, very close. You want to keep going. I can't see who's talking. Sorry.
Well, Debbie's age doesn't double. She ages 5 years and so does Joanne, and then her new age is double what Joanne's new age.
This is
Twice Debbie's age.
we've poked a hole in something, which is good. Okay. We're missing one tiny piece. Tobias.
Like, so if you're saying, let me just like wrap my head around this. So if you're saying that, like, both of their ages combined equals 59,
Yes.
right? But then you're saying 5 years from now. So both, like everything in the first equation goes up by 5, right?
Yes. Okay, let's start there. That's good. Let's start there. That's fine. Let's just, one sec. Before you keep your thought, let's start there. Okay? I'm going to restart this equation. It's not that it was wrong. It was close. Okay? Tobias said in 5 years' time, everything increases by 5, correct? D plus 5 is equal to J plus 5. Now, what else does it say?
Twice Debbie's age.
Twice Debbie's age.
So what is B plus 5 times 2? Is that what it is?
Twice Debbie's age will be equal to Joan's age. 2.
That's what I meant.
There's one, you were very, very close. You just missed the fact,
5, that's what I
you,
thought it
yeah.
was.
You said Debbie stayed at the same age, or the time hadn't gone on for Debbie. It was good. That's why I ask you guys these questions instead of writing it down, right? So we can talk through it. Because I wouldn't have normally thought of, okay, well, let's, right off the bat, we're going to add 5 to both, because time went on. Then we're just going to slot in the fact that, whatever it said next, that Debbie's age was twice what Joan's was in 5 years. Remember, both of these are very specific conditions, right? But they can be represented by lines. And we can use both those lines to figure out how old they are in this instance. Okay? What would, yes, Tobias?
So I'm still a little confused because I've kind of done some math beyond this point, and
You mean in this question?
yeah, this question. And if you're taking, so if you have this, like you have Debbie's age and then Joanne's age, like the 2 bracket D plus 5 bracket. D
Yeah.
plus J plus 5.
Yep.
And also in the first equation, you have to bump up the 59, right? Like what both of their ages add to a 69, right?
Yeah, but it's doing, that's why we made our let statement to be right now.
Both of their ages go up by 5, doesn't mean.
So if we say that their ages are current, or sorry, they're right now, their age right now, then in 5 years' time, it's going to be right now plus 5. That's what I mean. The let statements can be very tricky from the beginning to come up with. Because they need to, we're basically asking you to come up with let statements that are going to represent your final answer without actually knowing what the final answer is. It's tough, right? That's what makes them hard. Okay. What I'm trying to show you is always, they can be very hard. You try to fall back on, let's break this down into words, break it into 2 halves. Each half represents an equation. Start substituting orders of operations for specific words. Work your way through it. You're going to get something that's close, right? Does that make sense? This is what I fall back on all the time. Okay? Once we're at this stage, we can just solve it. Okay? All right, well, this question kind of sets up nice for substitution again, right? Because if I take the 5, I'm going to do something first. I'm going to get rid of the jail bars on the left first, okay? To do that, I'm going to multiply in. Yeah?
Wait, shouldn't the 5 be outside the brackets? Because then it wouldn't be going up by 10 years. Should it be like 2 and then bracket D, bracket then plus 5? So you add the 5 on after you times her age by 2?
No, it's because her age in 5 years is.
Is also double. She will be. Yeah.
Because Joanne's age, Coco, Joanne's age in 5 years is 2 times Debbie's age in 5 years.
Plus 10.
Where's the plus 10?
But that's what I mean.
The plus 10 is like,
10 instead of plus 5.
it's saying
So, yeah, 2 times 5 is plus 10.
plus 10. It's what it's saying is it's like in 5 years. 5 years has gone on. I don't know. It's just the math, Coco.
Okay.
It's just the way it's set up. We could try it to do it the other way too. You'd see it. You're gonna get funny numbers, right? Okay. So we're gonna go 2D plus 10 is equal to J plus 5. And then you're just gonna, I would just get J by itself with this equation. Yeah, I'm gonna get J by itself with this equation here.
Oh wait, so then when you like, if you want to switch the 5 over to the other side, if you
So you subtract.
subtract it from
Yep.
the side.
Yeah, you just subtract from both sides. So I get 2D plus 10 minus 5 is equal to J. 2D plus 5 equals J. That's what it's saying, isn't it? Maybe that answers your question, right? That's what I mean. Sometimes the math is the math, and then it works itself out as you start to work through it, right? Have a more literal meaning. Okay. Once you have this, you know what J is equal to. You have two equations on your page now. 1 and 2. I see a J up here in the first equation, which I could replace with this piece. So what I'm going to do is go over here. I'm going to go D plus J, which is going to be 2D plus 5, is equal to 59. Okay. I always insert brackets just for my own personal, like, it's like a safety blanket. So if there's a negative sitting there, something funny going on, I can deal with the negative. Okay. I know if I insert the brackets and I see a plus sign here, I don't really have too much to worry about. If you have a negative, like some of you saw with 1C at the back, if there's a negative sitting here, now the brackets are important because the negative is going to go on both things inside. That's why I always insert the brackets. Okay, for our question though, it's a plus, so I don't have anything to worry about. The signs inside the bracket are the signs inside the bracket, they're not going to change. So you can basically just get rid of them and then collect like terms. Okay, so D plus 2D is going to be 3D plus 5 is equal to 59. 3D is equal to 59 minus 5. Okay, 54, divide both sides by 3. D is equal to 54 divided by 3 is what? What would be 60 divided by 3? 20. 60 minus 6 is 54, so you're going to take 2 3s off. It's going to be 18. Okay. Then you could take this. You could plug it back into the second equation for D and find out what Joan's age is. 2 times 18 plus 5 is equal to J. 36 plus 5 is equal to J. J is equal to, therefore, Debbie's age now, I guess it would be important to specify it now instead of 5 years from now, right? Because that's what your two variables you said they were, is 18. And Joan's age once you have the age now, it's obviously very easy to go, okay, well, 5 years from now, Debbie's going to be 23 and Joan's going to be 46. Right? You could confirm that with the other two equations, or the other equation, I guess. Are we good?